Hello, this is Ms. DB, and in this video we are going to learn about solving equations by adding or subtracting. This is Chapter 2, Section 1. Our objective is to solve one-step equations in one variable by using addition or subtraction. And we're going to practice using the steps on doing the operation correctly so that when our equations get more and more complicated, we'll have these steps down. So first of all, just some vocabulary, some overview of what we're going to be doing. An equation is a mathematical statement that two expressions are equal. So an equation always has an equal sign. A solution of the equation is a value of the variable that makes the equation true. So it's going to be the number that we solve for that makes the equation true. Here's how we find the solutions. What we do is we call it isolate the variable. We get the variable by itself. So when we get more complex equations, it's still going to be our goal to isolate the variable. There'll just be more steps involved to do that. In these examples from Section 1, there's only going to be one step needed to isolate the variable. It's isolated when it appears all by itself on one side of the equation and not on the other side at all. It can either be x equals some number, or it can be some number equals x. It doesn't matter if it's on the left or the right side, as long as it's the only variable there, there's just one x, or y, or a, or b, or whatever the letter is, and it's equal to some number. This is the first part of your worksheet. It has an overview of what an equation looks like. So here we have x plus 8 equals 5. So there's the equal sign. It has to have an equal sign. To balance an equation, you do the same thing to both sides of the equal sign. It's very important that we practice showing this step today and tomorrow and when we're doing the simpler equations. So what we do is we look at what operation is being done to the variable right now. Well, 8 is being added to it. So the inverse of adding 8 is to subtract 8. So we subtract 8 from both sides of the equal sign. And what we did then is we isolated the variable because 8 minus 8 is 0, so all we have left on the left side is x. And then we put our equal sign. And then on the right side, we had 5 minus 8, and we get negative 3. So the solution is x equals negative 3. So for your first few questions, you're going to answer these questions to make sure that you understand about the vocabulary and the steps involved in solving an equation. This is just a little bit more about that, about how an equation is like a balanced scale. And to keep the balance, you have to do the same thing on both sides. So if the variable had something added to it, that's addition. The inverse to addition is subtraction. And if the variable had something subtracted from it, the inverse is to add. So sometimes we'll add a number to both sides, sometimes we'll subtract a number to both sides. These are the properties of equality that let us do what we're going to do to solve an equation. The addition property of equality says that you can add the same number to both sides of an equation and the statement will still be true. So we have 3 equals 3. That's a true statement. If we add the same number to both sides, like 2, we get 5 equals 5. It's still a true statement. In algebra, we do this to solve equations. So we wouldn't do it with this many letters, but that's basically what we're doing. There's also a subtraction property of equality that says that we can subtract the same number from both sides of an equation and the statement will be true. When I say both sides, I mean the left side of the equal sign and the right side of the equal sign. The equal sign divides your equation into two sides, the left side and the right side. So that's what we mean by the two sides. All right, let's practice. Here's an equation to solve. So when I write your directions for your worksheet, I'm going to say show your work or show your steps and to check your answer. So make sure you do that, even though you might be saying, I can do this in my head. But we're practicing. This worksheet is not about can you tell me what y is. It's about can you practice solving equations using the correct format and the correct steps so that as they get more complicated, which they will even by the end of this week, you'll be able to use this good practice to find the answer. Okay, so right now, first thing I always do is I say, what's the variable? Our variable is y. And what is happening to y? Right now, what's happening? What's the operation happening to y? It has 8 being subtracted. There's a minus 8. So then you say, what's the opposite of subtracting 8? And the opposite of subtracting 8 is adding 8. So we just write a plus 8 underneath both sides of the equal sign. Now we simplify what we have. So we have y minus 8 plus 8. You might also see, sometimes you might learn it this way. You take y minus 8 equals 24, and then you say, well, what's the opposite of minus 8? And it's plus 8. So sometimes they write it in a line like this, in a one vertical line, which is fine. If you're used to doing it that way, that's fine. And then you go minus 8 plus 8 is 0, so you'd get y equals, you'll get the same answer either way. So you either have to show your steps this way, this method, or this method where you put the plus 8 underneath both sides. In this case, we also get y equals 32, of course. Now for the checking of your answer, you don't necessarily have to write it out like they do, but you do have to show that 32 minus 8 is indeed equal to 24. So 32 minus 8, I often will write like an equal sign with a question mark by it. And then I do the work and I say, yeah, it's 24. So you can just do this off to the side. You can say, you put what you got for y back into the original equation for the variable. And then one more step to say, yep, that's equal to 24, so it checks. Just a real quick little check. Now this one has fractions, and a lot of people think that as long as it has fractions, it's going to be really hard. But if you look at this example, they both have 16ths as their denominator. And the rule for adding fractions or subtracting fractions is that you have to have a common denominator. We're going to have that part already. So this is not really going to be bad at all. So we're going to, the variable is z. What's happening to z? Z has 7/16 being subtracted from it. So the opposite of subtracting 7/16 is to add 7/16. Now 5/16 plus 7/16, the rule for fractions is you keep the denominator the same and you just add the numerators. So that's really quite easy. I wouldn't mark it wrong if you left your answer as 12/16, but this can be simplified because you could divide top and bottom by the same number, by 4, and get 3/4 for a simpler fraction. It's actually easier to check this one if you leave it as 12/16. And then you can put your 12/16 right here, and 12/16 minus 7/16, yep, that's 5/16. So that one's easier to check if you don't put it in simplest form. All right, this one has decimals, but decimals are not bad. We will still do the same thing. We will find the variable, it's n. Right now, n has 3.2 being subtracted from it. So the opposite of that is to add 3.2 to both sides. And then we will get 8.8. So n is equal to 8.8. And then the check, which is very quick on these short little equations. Okay, here's the problems from your worksheet. Let's look at number 6. Number 6, we have 17 equals x minus 4. Find the variable. It's x. What's being done to the variable? It has 4 being subtracted from it. The opposite of subtracting 4 is to add 4. 17 plus 4 is 21. On the right side, the minus 4 plus 4 is 0, so we just are left with x. And a quick check is we write our equation, except we put a 21 in for x. And then we say, is 17 equal to 21 minus 4? Yes, it is. I want to do number 9 because, again, a lot of people don't like fractions. But look at what this is. This is really simple little fractions. We have 1/2 equals t minus 1/2. So our variable is t. What's being done to the variable? It has 1/2 subtracted from it. What's the opposite? To add 1/2. What's 1/2 plus 1/2? If you have half a sandwich plus a half a sandwich, you have 1 whole. So we get 1. Now let's check that. Is 1/2 equal to 1 minus 1/2? If you have 1 and you take away a half, do you get a half? Yes, it checks. It's both equal to 1/2. All right, now sometimes you have a number being added to the variable. Lots of different things can happen to the variable, so you have to first identify what's happening to the variable. The variable is m, 17 is being added to it. So our first step is to undo that by subtracting 17. So we subtract 17 from both sides. 33 minus 17 is 16, m equals 16. These are really easy to check because you're just going to add the two numbers together, which we're all pretty good at, and 16 plus 17 is 33, so it works. Here's one with the decimal. Remember to have a calculator. You should all have a calculator. Don't use the ones on your phone. Go get a calculator. They're like $9 or $10 or $11 at the store. You can get one on Amazon for like less than that, like $8. So get a scientific calculator and then type in 4.2 minus 1.8 and make sure you get the right answer. It's 2.4. And then you can use your calculator to help you check as well. Check that 2.4 plus 1.8 is indeed 4.2. And it is. Here's one with the fractions, very, very similar to the one I just did. We have d as the variable. We're going to subtract 1/2 from both sides because that will undo the adding 1/2. What is 1 minus 1/2? We talked about this. If you have one sandwich and you take away half, you have a half left. And of course, 1/2 plus 1/2 is indeed equal to 1. Here are the problems from your worksheet. These are not very tricky ones, but let's look at number 11 because I've had people tell me that the answer to this is 18. So the variable is n. I have 9 being added to it, so I need to subtract 9 from both sides. 9 minus 9 is 0. So my answer is 0. I can check it by plugging in 0 here, and that does give me 9 equals 9, so that works. In number 14, the fraction one, you're going to subtract 1/3 because that's the opposite of adding 1/3. So let's think about this. We have one, let's say it's one rectangle, and I have this rectangle divided into thirds, somewhat unevenly, but pretend they're even, and I need to take away 1/3. Break that piece off. What's left? 1 2/3. So 1 minus 1/3 is 2/3. And you would check that by thinking to yourself, or writing to yourself, is 2/3 plus 1/3 equal to 1? Well, sure it is. Here's the 2/3, here's the 1/3 I took away, and that would be 3/3. All right, here's two things to remember when solving these equations to kind of stop and look at. First of all, subtracting is the same as adding the opposite. So if you are solving equations, you'll sometimes find it easier to add an opposite to both sides instead of subtracting. And I'll show you what that looks like in the next page. Here's another thing. If you are subtracting a negative, like minus a negative, it's a lot easier to rewrite this as adding the opposite. Because, again, subtracting is the same as adding an opposite. So if I rewrote this sentence as x plus 2, which is what x minus -2 is, it's going to be much easier to solve than going, okay, wait, I have to add, let's see, I have to add the opposite of -2. No, I have to add -2. So see how confusing that gets with all of these negatives? So I'd have to add -2, or you can just subtract 2 and get 6. It's much easier if you rewrite this. When you see a minus and negative, you can change that to plus. Here's an example of what I was talking about. This is technically, here's the variable m. Technically, we're adding -2.3. So the opposite of that would be to subtract -2.3. But isn't that kind of confusing? So it's easier, generally, to instead of doing that, to just go ahead and add 2.3. So the opposite of -2.3 is a plus 2.3, so we can add 2.3, because really what we're trying to do is undo this, and that will accomplish that, adding 2.3. So we add 2.3 to both sides, and we get 9.3, and if you check it, you'll see that that works. That does give us 7 for our solution. All right, so here's some of those kind of trickier ones. let's look at the last one here, 21. So we have 2.8 equals negative 0.9 plus y. I want to undo this, the negative 0.9, so that I have just y by itself. So the easiest thing is just to add 0.9 to both sides. I usually just forget the 0 in front and write that, which is fine as well. And then again, you're welcome to grab your calculator there and check that 2.8 plus 0.9, I got 3.7, and that's what I get for y. And then I'm going to check this one by putting in 3.7. And I'm going to use a calculator again and say, okay, if I have 3.7, or if I have negative, make sure you know where the negative key is on your calculator, which is another reason to have a handheld calculator, because they have a negative sign on them, whereas like if you're just using some app on your phone, it might not have a negative. You might have to use a minus and it might not work right. Anyway, this checks and we have the right answer. So for number 18, I would rewrite this as x plus 5 equals 9, and then I would solve from there. Same in 20, I'd write y plus 3 equals negative 9. Okay, on this page you're going to practice. Sometimes you'll have to add, sometimes you'll have to subtract, sometimes you might want to simplify first. So do your best on here, use all the rules that we have used in the other problems, and be careful. All right, number 28 I want to talk about. Here we have angle XYZ, that's this one down here, is congruent to angle ABC. So they have the same measure. So if two angles are congruent, they have the same measure. Angle XYZ is 50 degrees. Angle ABC is marked 15 plus x. Well, if they're congruent, we know that this 15 plus x is equal to 50. So that's your first step here, is to write that 15 plus x is equal to 50. They're congruent, so their measures are equal. And then you're going to solve this equation for x. You're going to find quite a few geometry questions like this over within Chapter 2, which will help you be prepared for taking geometry, which most of you will take next year. All right, that's it for today. Please let me know if you have any questions. Send me an email, come to my office hours, or go to the ASC room to get help. Thanks a lot and have a wonderful day.